The first thing I want to do is section 3-4 though. So those are the first and back page, front and back page 1 and 2 of your handout, this one, the quiz review handout. Those are just like graphing inequalities. I just want you to graph the systems of inequalities, which means you're graphing 2 lines, you're shading 2 lines, and where the 2 lines shades cross over, that is your answer, okay? There are 2 types of those. You can be given it in slope-intercept form, which is this first one, y equals mx plus b, or you can be given it in standard form, ax plus by equals c, or greater than less than specifically for these, right? So I want to show you one of each of those. And then we're going to flip over to this other one that y'all did, and we're going to do some of those together, okay? Really the ones that I did for you, but then show you how I did it, okay? So the first thing you need to know is just how to graph inequalities. And you're going to graph them like you do lines, and then you're going to shade them. So for this first one, I have y is less than or equal to negative 6x minus 3. This is slope-intercept form. When you are graphing in slope-intercept form, where do you start? With the y-intercept, which is this guy right here, and you start on the y-axis. So I go to negative 3 on my y-axis, and I put a dot there. The next thing I do is I look at my slope. That's the number in front of the x. In this case, it's a negative 6. Remember, it's technically a fraction. This one is negative 6 over 1 or positive 6 over negative 1. Both of those equal negative 6, right? Why would I write it a different way? Well, the top number tells me to go up or down, and the bottom tells me to go left or right. What happens if I go down 6 from negative 3 on this particular graph? So on this particular graph, I would go off of the graph if I did the first way. So I'm going to go up 6 and left 1. That's the same exact thing. So I just start here and I walk up 1, 2, 3, 4, 5, 6. And because I went up 6, I need to go left 1. And that's going to put me right there. And that's going to be my second dot. Now that I have 2 points on any line, I can graph it. I just need 2 points. And so once I have that, I am going to connect those 2 dots and I'm going to graph it. I do need to decide if this is a solid or a dashed. Is this particular guy solid or dashed? Why do I know that? Or equal to. That's really important. Or equal to. So I am going to do a solid line here, right? And then I am going to move on to the next line. Now, if you want to, at this point, decide where this shading would be, you may. On your quiz, I would recommend either doing 2 light colors and then darker, or if you're using just a pencil, do it very, very lightly and then darken exactly what you want me to know. If you want to shade at this point, you may. Less than is going to be the side of it that goes below. So if my y is here, it's going to be everything down here, which means it's going to be basically on the left side of this graph if you look at it that way. So my shading for this piece would be right here. All right, for the next one, what is my y-intercept for this guy? Well, it's positive 2. So I'm going to start at positive 2. My slope is negative 1, which means negative 1 over positive 1 or positive 1 over negative 1. All right, both of these will keep me on the graph, but I can go down 1 over 1, which puts me here, or I can go up 1, left 1, which puts me actually exactly crossing where my other one was. Is this one solid or dashed? This guy is dashed because it is just less than. So I'm going to dash this one. When I look at this one, I can see this is less than. So I am going to shade everything below that line, which is right here. So if I were to say, what is my answer? My answer is going to be where they cross. So my answer is going to be this right here, where they cross. Okay, so that's where you may want to shade really lightly, and then darken what your answer is so I can tell. So the second page of this is all in standard form. They're all in standard form. Really the easiest way to do, if you want to convert them all to slope-intercept, you are more than welcome to. If you are just, I must graph and slope-intercept, perfectly fine. Pay attention to your negatives in front of your y's, because when you divide this negative 2 over, it does flip your sign, and you have to divide every piece by negative 2. So if you move your x over and divide by the number in front of your y, that's perfectly fine. Just pay attention to your rules of division and your rules of greater than less than. Or you can graph with intercepts. That's how I typically graph it in standard form, and that's how you're probably going to want to do it on your word problems. All right? So if I were to do this in intercepts, I would say, well, the first one, the x-intercept is going to be -6 over the number in front of my x, which is just 1. So my x-intercept is -6, 0. My y-intercept is going to be the -6 over the number in front of my y, which is -2. So it's going to be 0, +3. All right? And then I graph those two. I go to -6 on my x-intercept, which is really great because they didn't actually give it to me. I'll make sure that I give it to you. And then I go to +3. +3. All right? Now, then once I have 2, I determine is it solid or dashed. In this case, it is solid. I mean dashed, not solid, sorry. The second one is solid. So I dash this guy right here. And then if you want to go ahead and shade, you can decide, is it below or above? It looks like it's below. What's the problem? I have a negative in front of my y. What is that going to do to him? It's going to flip it. So it's going to be everything above this guy. So everything above this is going to be what is shaded here. Okay? Then I'm going to move to the next one. The next one, I will look at my x-intercept. My x-intercept is going to be the +2 over the number in front of my x, which is 1. So it's going to be 2. My y-intercept is going to be the +2 over the number in front of my y, which is 2. So it's going to be at 1. So I'm going to go to 2 on my x, to 1 on my y. This guy is going to be solid. So I'm going to connect those two. All right. And then it says less than, and it doesn't flip because there's a positive. So it's going to be everything below this line. So everything below this line. But what crosses? Well, the only thing that crosses is this part right here. That's the part where they cross. That little triangular area right there. So it doesn't actually include any of this up here, right? It doesn't actually include any of this down here. It only includes where they cross, which is right here. Particular one. It says find the values of x and y that maximize or minimize the objective function for each one of these. And they actually gave you your objective function. They told you that your objective function is this guy right here. That is your objective function. All right? And so you don't even have to solve for it. They told you what it is. What you do need to figure out is where the vertices are. So they have graphed your constraints. This little shaded area is called your feasible region. You really just have to figure out what is my vertex for each one of these. Well, I have one right here. That is 0, 0. I have one right here. That is 8, 0. I have one right here. That is 2, 6. And I have one right here. That is 0, 6. All right? So once you have your feasible region graphed, you really just have to figure out your vertices, and then you're going to plug them into your objective function. And so that's what I did on that little handout that I showed you. I literally just plugged it in. 6 times 0 plus 2 times 0. 6 times 8 plus 2 times 0. 6 times 2 plus 2 times 6. And 6 times 0 plus 2 times 6. All right? And so for these, you're going to get 0 when you plug it in. You're going to get what? 48, I guess, when you plug that in. You're going to get 24. You're going to get 12. All right. If you wanted a max and a min, the lowest is the min, the highest is the max. All right. So that's the first type that you can get, is they just hand it to you. The next type is like number 3. They basically handed you everything you needed. Let's look for 3. They handed you your objective function, the profit equation. They want you to maximize it. The only thing they didn't do is they didn't graph these guys. So you need to graph them. And so you're going to graph them exactly like you just did in section 3-4. You're graphing all of them and seeing where they cross over. All right? And so if I were to graph this first one, my x-intercept is going to be 6 over 1, so just 6. My y-intercept is going to be 6 over 3, so that is 2. And then I am going to connect those dots. They limit it to the first quadrant, so I don't even have to worry about anything other than those. It's going to be greater than, so I know eventually I'm going to shade above that line. The next two are horizontal and vertical lines. X equals 8. Well, that's over here, straight up at the 8 on the x-axis. X equals 8. Y equals 7. That's on the y-axis at 7. And that's going to be a horizontal line there. All right. So if I were to say, what region am I going to shade here? I want everything above the blue line. It's less than 8, so everything to the left of 8. And less than 7, everything below 7. So if I were to shade this region, I'm talking about this guy right here. And then I am going to do exactly what I did before. I'm going to plug in my vertices into the profit. So I need to figure out what my vertex for each point is. Here's one right here. So I have the point 0, 2. I have one right here. That's the point 6, 0. One right here. That's the point 8, 0. Right here is the point 8, 7. And right here is the point 0, 7. Right? And then I take every one of those and plug it into my profit, right? And figure out what's my highest profit. I have 0 plus 3 times 2, that gives me 6. 6 plus 3 times 0, that gives me 6. 8 plus 3 times 0 gives me 8. 8 plus 3 times 7 gives me 29. And 0 plus 3 times 7 gives me 21. What's my maximum profit? And where does it happen? My maximum profit is $29, and it happens at the point 87. Okay? These are identical to what we just did. It's just you have to gather the information from what they have told you. So we're going to walk all the way through this one, and then we're going to slightly walk through some of the others, meaning I'm not going to solve it for you, but I'm going to walk you through the setup because I think that's the hardest part. The Booster Club sells hot dogs and hamburgers during football games. In order to make a profit, they must sell at least 12 hamburgers, and they cannot cook more than 60. They also need to sell at least 40 hot dogs, but cannot cook more than 70. They cannot cook more than 100 sandwiches altogether. The profit on the hamburger is 75 cents, and on the hot dog is 50. How many of each kind of sandwich should they sell to make the maximum profit? I will tell you, I will make sure that yours go in the same order because my brain has gone crazy with this word problem because I don't like how they worded it. Why do you think I don't like how they worded it?
Very big.
All right, so you must set up variables for each piece of it. Do you see why I say label it? Because of this crazy word problem, all right? If you make your X a hot dog, you need to write somewhere on here that X represents hot dogs because I promise you, you will mess this up on something like this, all right? So if your X is hot dog, write it down. X is hot dog. Y is hamburger. You need to write it down so that you remember, okay? The first thing I do is figure out my profit equation. I always start with what are they trying to maximize or minimize, all right? And so I really, really recommend that you do some type of coloring, whether it's highlight or colored pencils. I recommend that on these problems. So if I say I am going to look at the profit equation, then I need to immediately read anything that has to do with profit. Well, my profit equation actually waits till the very end. The profit on a hamburger is 75 cents and on a hot dog is 50. There we go. That's my profit sentence. And so if my X value was hot dog, my profit on my hot dog is 50 cents. That means I need to take 50 cents times every hot dog that I sell. Then I'm also going to consider my hamburgers. My profit on my hamburgers is 75 cents times my hamburger variable. So I immediately picked out my profit equation here, right? Now I'm going to look at constraints. By definition, constraint should bring up the thought of a limitation, okay? And so I'm going to look at what limitations they have given me. They have given me 3 limitations. The first limitation they said dealt with hamburgers. All right. I have to sell at least 12, but not more than 60. So my hamburger amount has to be between 12 and 60. A minimum of 12, a maximum of 60, okay? So how would I write that? Well, I would say for hamburgers, I have to have at least 12, and no more than 60. And look what I just did. My hamburgers is which variable? What's my hamburger variable? It's Y. But they did it in the wrong order. All right. So why do I know that? Because they said I have to sell 12, but no more than 60. That's a limitation. Anytime they give you this between thing, you're going to have something that looks like that. Okay. I have to sell between 12 and 20 muffins. All right. You're going to have some variable between 12 and 20. All right. They did the same exact thing for hot dogs, by the way. So if you look, they need to sell at least 40 hot dogs, but cannot cook more than 70. That's my next constraint. So now I'm going to have that my hot dogs is between 40 and 70. That's my next constraint, right? And then I have one more constraint. They cannot cook more than 100 sandwiches all together. So my hot dogs added to my hamburgers cannot be more than 100, which means it's less than or equal to 100. So if I take my hot dogs and add it to my hamburgers, it has to be no more than 100. That's the most they can sell. Why that is, I don't know. But that's what they said. No more than 100 together. Does everybody see my constraints? Now you'll notice your graph is only in the first quadrant. There's a natural constraint. All right, even if they hadn't said between 12 and 60, and between 40 and 70, there's a natural constraint. They're not going to sell a negative number of hamburgers or hot dogs, right? And so most of your word problems will naturally constrain you to the first quadrant. Now this looks identical to the one I just did. I have a profit, I have constraints. I'm going to graph my constraints, take my vertices, plug it into my profit. All right, so we are now going to take exactly what we just had, graph your constraints. All right, very easy to graph these actually. So the first two are going to be 2 vertical lines, 2 horizontal lines, right? My Y, those are horizontal. So I'm actually going to go to 12. These are every 10, by the way. These little markers are every 10. And so they just mark it every 20, but the dashes are every 10. So if I graph this Y, then I'm going to graph one at 12. That's just above that 10 line. And then one at 60 up here. And it's going to be in between those. In between those is where my thing is going to be. And then I'm going to do the same thing with my vertical lines, my X between 40 and 70. So I'm going to go to 40 and graph a vertical line there, and to 70 and graph a vertical line there. All right. For these word problems, it's typically easiest to graph using your intercepts. Okay. So if I look at this guy right here, my x-intercept is going to be 100 over 1, which is just 100. That's right here. My y-intercept is going to be 100 over the 1 in front of my y. So my y-intercept is also at 100, which is right here. And then I'm going to draw that line. They were fairly nice to me when I draw this line. And I'll show you how to figure out where it crosses, okay? All right. So what is my feasible region? What would I shade here? Well, I would shade everything that's in between the blue, in between the red, and below the purple. So it ends up being this little crazy guy right here. This part right here. This is my feasible region. So I need to figure out the vertices for this feasible region and plug it in. So I have a vertex right here. Well, my x value here is 40 and my y value here is 12. I know what those lines are. It's really nice when it's vertical and horizontal lines, okay? 40 and 12, that's that guy right there. This one is 40 and 60. I know my blue line is 40. I know my red line is 60. So that's 40 and 60. This one right here is also easy. It's 70 and 12 because I know what that blue line is 70. That red line was 12. All right, this is the one I actually need to figure out right here. It looks like it's going to be 70 and like 30, but I need to figure it out. Well, how would I? I know for a fact my x value is 70, right? Because I know that this line is x equals 70. So I already know my x value. My x value here is 70, all right? My y value, well, my y value is based on this purple line. So right here, I know my x value is 70, right? Because that's what this whole entire line is 70. If my x is 70 and the two added together equal 100, what is my y value? 30. So this guy is 70, 30. Those are my vertices. And I just plug it into my profit equation, all right? So I'm going to plug it in. What happens when I do 0.50 times 40 plus 0.75 times 12? So go ahead and calculate those. What are they? What is my profit at each one of those? Plug them in and solve. Plug them in and solve. All right, based on this, what is your most profit? Which of these gives you the most profit?
65.
The $65. So here's how you're going to answer this question. You would say my maximum profit is $65 and it happens at 40 hot dogs and 60 hamburgers. All right. So you need to also be able to interpret it. What did you tell me? You make the most profit when you sell 40 hot dogs and 60 hamburgers, and that profit is $65. Okay? Let's just talk through some of these. I want to talk through them so you can start get a feel for what you're doing. You're taking an exam with multiple choice questions worth 5 points. Short response questions worth 8 points. It takes 2 minutes for each multiple choice question, 6 minutes for each short answer. The total time allowed is 60 minutes, and you may not answer more than 18 questions. Assume that you answer every question correctly. How many questions of each type should you answer to get the highest score possible? What are you trying to maximize? Your score, right? So your profit equation is anything that has to do with how it is scored, okay? So if I were to look at this particular one, I would say highest score possible. What did they tell me about scoring? They said multiple choice is worth 5 points and short response is worth 8 points. So what are my two variables that I don't know? Well, I do not know how many multiple choice problems, and I do not know how many short response problems to answer. All right? And so if I were to write a profit, quote unquote, equation, it would be based on a score. That is what I am trying to maximize here. And then I would take those variables and I would say, how much is each multiple choice worth? 5. 5x. How much is each short response worth? 8. 8y. There we go. I have an objective function. They give me some limitations. My limitations are time and the number of questions I can answer, which seems an odd limitation on a test, but whatever. All right. So time. Time is a limitation. Even if you have to write the word time. Time is a limitation. What is my limitation on time? Well, it takes 2 minutes for a multiple choice, 6 minutes for a short answer. The limitation is the total time allowed. So how do I write that out? Well, multiple choice, 2 times x. Short answer, 6 times y. Together, those cannot be more than 60 minutes. Limitation, all right? They have given me another limitation. You may not answer more than 18 questions. So if I take all of the multiple choice and all of the short response, they have to be less than 18, how many I answered. So that's what I'm going to do. My next limitation is the number of questions. So if I say x, because I don't know how many I'm going to have, and y, I don't know how many I'm going to answer, I do know that has to be less than 18. I have my constraints. I have a natural constraint here. What's my natural constraint? First quadrant, I can't answer a negative number of questions. I can get them wrong, but they already told you, assume you got them all right. Anything that you answer, you get right. That would be nice, right? So I am automatically limited to that first quadrant. I'm not going to make you list it. I'm not going to make you say x has to be greater than or equal to 0, y has to be greater than or equal to 0. But that's a natural constraint here, okay? And then what do? You graph those. You figure out where they cross each other. And then you do your vertices. How would I figure out where I cross? Well, you can do it by elimination. Multiply the second one by -2 and eliminate to figure out where they cross if you need to. Graph by intercepts. Your x-intercept here is going to be 60 over 2. That's 30. And even if it won't let you get there, I will make sure, by the way, that you have your intercepts available on your graph. Okay. Y-intercept, 60 over 6. X-intercept is 18. Y-intercept is 18. Okay. And obviously 0, 0 is going to be one of your vertices here, but you probably don't have to test it because your score would be 0 if you did that, right? So this is the same exact concept as what we just did. Profit or objective equation constraints. All right, let's look at one more and then I'm going to let y'all work for the last few minutes. Tommy's making banana bread, zucchini bread for a bake sale to raise money. A loaf of banana bread takes 2 cups of flour and 2 cups of sugar. Zucchini takes 3 cups of flour and 1.5 cups of sugar. He has 12 cups of flour and 9 cups of sugar. He makes $2 profit on the banana and 3 on the zucchini. What are my variables going to be? Banana and zucchini. That's my X and Y. Profit. They actually say the word profit here. What's my profit on my banana bread? $2. $3 on zucchini. There's my profit equation. What are my limitations? He has 2 limitations here. What are they? How much flour he has, how much sugar he has, okay? Now here's the thing about this one. They listed it by the bread, not by the limitation. What do I mean by that? If 12 cups of flour is a limitation, I need to look at everything that has to do with flour. 2 cups per banana, 3 cups for zucchini. That's my flour limitation. If I have a limitation on sugar, he only has 9 cups of sugar. I need to look at everything that has to do with sugar. 2 times my banana bread for sugar, 1.5 times my zucchini for sugar. Okay? Does that make sense? So you need to find your objective or your profit, and then you just say, what are my limitations? Now, everything that has to do with that limitation is going to be in one equation. Everything that has to do with the other is going to be in the other equation. Graph your limitations, test your vertices. All right, questions?